Hello everyone, welcome to MedStats. First of all, I would request you all to subscribe to our channel for more videos. So today we are going to talk about interpreting results of t-test in SPSS. As in my previous video, we have already discussed how to do t-test in SPSS. So now in this video we are going to discuss how to interpret the results that we obtain in t-test using SPSS. First of all, before knowing or how to interpret the results in SPSS, we should know about variance. What does variance mean? Variance is a measure how far each number in a data is deviating from its mean values. For example, I have a data set of numbers ranging from 1, 2, 3, 4, 5 and 6. So the mean value for this data is 3.5. Then I can calculate variance by first finding out the difference between each data value, or by first subtracting each data value from the mean value and then squaring all these differences, adding them and then dividing them with the total number of samples. That means first I will subtract 1 from 3.5, 2 from 3.5, 3 from 3.5, 4 from 3.5, 5 from 3.5 and 6 from 3.5. Then I will square all these differences, then I will sum all these differences and then I will divide it with the total number of samples, that is 6. Then I will get a variance called as 2.91. So variance actually means that how far each value is differing from its mean value. Then coming to variance in t-test. In t-test generally, or in independent sample t-test, we get two mean values. That means we get two variance. So to find out whether these two variances are equal or if they are not equal, we have to do one test called as Lebanese test for equality of variance. So when we do a normal t-test or an independent sample t-test, SPSS will automatically calculate this Lebanese test for equality of variances. So whenever we do an independent sample t-test in SPSS, we get two tables. The first table is group statistics table and the second table is independent sample t-test table. So in the first test or in the first table, in group statistics table, the second column indicates the total number of samples that are present in each group. That means in my study I have 7 males and 23 females, and the mean values or the mean age of males is 56.14 and the mean age of females is 50.74. Then coming to standard deviations are given in the next column and followed by standard errors. Then coming to the independent sample t-test, this independent sample t-test table is mainly used to analyze or to assess the p-value of this group statistics table. So here the p-value is given with a heading called as significance two-tail. So but there are two p-values here. One is 0.309, another p-value is 0.257. So in the second table we have two p-values. One is 0.309 and another one is 0.257. So which p-value should we assign to this group statistics? That is either 0.309 or 0.257. To find it out, we should do a test called as Lebanese test for equality of variances. So in SPSS, already this test is automatically done by the SPSS software, and here the p-value for this Lebanese test for equality of variance is given. In this study, the p-value for Lebanese test of equality of variance is 0.304. That means the p-value is greater than 0.05. That means it is not significant. So whenever the Lebanese test is not significant, then we should assume that equality of variances is correct, or that means the variance of these two means is almost equal. That means equality of variances are assumed in this table or in this study. So the p-value will be 0.309. In case if the significance or p-value of Lebanese test of equality of variance is less than 0.05, or if it is significant, then we should assume that the variances of these two means are not equal. That means here we can see a separate row called as equal variances not assumed. Then the p-value for this group statistics will become 0.257. So to find out which p-value should be assigned to this group statistics, we should first do a test called as Lebanese test for equality of variance, and if the p-value of the Lebanese test for equality of variance is above 0.05, then we should always think that equality of variances is assumed, and the p-value should be the first row, that is 0.309. If the p-value of equality of tests of variance is less than 0.05, then we should think that equality of variances is not assumed, and we should take the p-value of 0.257. So in this study, the p-value of equality of variance is above 0.05, hence the p-value for this group statistics will be 0.309, and it is above 0.05. So from these results we can finally sort out a table just like this. That is, the table describes the total number of samples in each group and the mean values, that is the mean age of males and the mean age of females, the standard deviations of these mean values, the standard errors of these mean values, and finally the p-value, which is 0.309. As the p-value is greater than 0.05, that means there is no significant difference between the mean age of males and mean age of females. That means both the groups have almost similar age group population. So with this we can finally conclude that the sample that we have taken have mean ages almost equal. That means there is no significant difference in the mean age of males and mean age of females. Thank you.